Hi there. Are you interested in physics? Well, I am. Trouble is, I'm not very talented. I'm certainly not talented enough to study physics on a professional level. But is physics only for the talent? Is soccer only for the talented? Last night our national soccer team was kicked out of the European Championship by Les Bleus de France. Today 70 million experts discuss the reasons why. A lot of them haven't played soccer for decades. Anything wrong about that? I don't think so. Fortunately, we live in a part of the world where people can freely talk about things they may or may not understand. So I decided if Donald Trump may talk about politics, I may talk about physics. Let's start out with the speed of light. The speed of light is constant, the experts say. How can we, the not so talented ones, explain that? In classical physics, speeds may add up. If a man running at a speed of 10 miles per hour is running in a bullet train that moves at 200 miles per hour, the running man will cover a distance of 210 miles per hour. A light beam has a constant speed of around 186,000 miles per second, no matter whether you start the beam in your own house or in a rocket flying at a speed of 20,000 miles per hour. How come? Well, in my universe, light is not a bullet train running on a continuous track that increases its speed when you push from behind. Instead, light is a kangaroo jumping from spot to spot in quantum leaps. When you push a kangaroo from behind, you're going to change its speed. First, the acceleration of a jumping kangaroo is so high that your push with your hand on its back will be too slow to influence its speed. Second, once the kangaroo has finished its first jump, you can't reach it anymore. If the speed of light was constant, in our picture, our light kangaroo would have to jump at the same frequency, covering the same distances all the time. How does light do that? Well, in my universe, space is not a dull continuum ranging from one end of the universe to the other one. It consists of gazillions of very small bubbles, space bubbles, and light jumps from space bubble to space bubble. This is why it covers the same interval at every single jump. Before we come back to the question whether the speed of light is always constant, let's talk about gravity. What causes gravity? In my little universe, it's resistance. Let's have a look at this little figure. We see 5 space bubbles. The center bubble, bubble 1, is filled up with the particle A. The other 4 bubbles are empty. At the bottom of our 5 bubbles, we have a large mass, for instance a planet. Between our space bubbles, we have resistances which can change. The large mass at the bottom of this figure increases the resistance between bubble 1 and bubble 2, and it decreases the resistance between bubble 1 and bubble 5, while it leaves the resistances between bubble 1 and 4 and bubble 1 and 3 almost unchanged. Supposing no external forces are working on particle A, what is particle A going to do? It'll choose the path of the least resistance, which means it will go from bubble 1 to bubble 5. So in my little universe, particles and electromagnetic waves that move from space bubble to space bubble are influenced by the resistance between these bubbles. This resistance is variable, and waves and particles will always choose the path of least resistance as long as no other forces are influencing them. What influences the interbubble resistance? Its mass and occupation. Let's have a look at this little figure, which looks familiar, but it has been changed slightly as compared to the previous one. We've talked about the influence of masses on interbubble resistance, which is the axis between bubble 2, 1 and 5. Now let's focus on the red arrow between bubble 1 and bubble 3. In this figure, bubble 3 is occupied by particle B. So particle A is prevented from moving to bubble B by the influence of mass, which increases the resistance between bubble 1 and bubble 2. And it's kept from moving to bubble 3 by the resistance caused by the occupation of bubble 3 by another particle. Of course, these resistances can be overcome by external energy. If you push particle A upwards, then it can still move to bubble 2 because the energy added to particle A may be enough to overcome the resistance between bubble 1 and bubble 2. And if you add enough external energy, of course, you can enable particle A to push particle B out of bubble 3. Let's move on to quantum mechanics. The double slit experiment seems to be the holy grail of quantum mechanics. There are fantastic videos on YouTube on the double slit experiment, so I don't want to go into details of the experiment itself. When you look at some of the videos, you get the impression that the interference pattern builds up slowly as more particles get through. And that doesn't seem to be an optical illusion. The interference pattern is interpreted as a proof that small particles like electrons or even small atoms or molecules have a particle nature as well as a wave nature. That seems perfectly understandable if you assume that it is the particles that cause interference. In my universe, it's probably space. If you shoot a number of electrons or other small particles through space, the interbubble resistances will change, and this will cause interference. At least this could explain why it takes a while for this interference pattern to build. So wouldn't it be interesting to do a modified double slit experiment with 2 or 3 electron cannons used at the same time, and the electrons crossing each other's ways, say at 90-degree angles? Poor little space would be completely confused, and the interference pattern might be disturbed. Now apparently you get the interference pattern only if you use particles which do not exceed a certain size. In my universe, you would only get interference patterns if you used particles small enough to squeeze in one single space bubble. If you used particles occupying 2 or 3 space bubbles at any given moment in time, you would lose the interference pattern. That means you could use this experiment to estimate the size of an individual space bubble. Wouldn't that be interesting? Let's move on to time. What is time due to? In my universe, time is due to oscillation. Now, what on earth is oscillation? In my universe, particles can't stand still in one space bubble. They constantly swing back and forth from space bubble to space bubble. And this is what I call oscillation. Time is not constant, the experts say. What slows oscillation or time down? When a photon moves at the speed of light from one space bubble to another one, it's so fast it can't swing back. It can't oscillate. No oscillation, no time. If you looked at a star 2 billion light years away from Earth, you could say that the photons that hit Earth are 2 billion years old. To the photon itself, however, no time would have passed. It wouldn't have aged on its trip to the Earth. It would be as young as it was when it started out. The photon would have traveled at infinite speed. Massive masses have a similar effect to oscillation as the speed of light. Particles can't oscillate anymore. Time comes down to standstill. Okay, folks, that's all for today. If that's not enough, I suggest you read Dr. Seuss, Oh, the Things You Can Think. Thank you.